Hello students, today's topic is dot product. We will see the dot product first and then we will dive into what is called as inner product. Okay, by definition, the dot product is nothing but for two vectors a and b in some real number r to the power n, the dot product is defined as a into b is equal to a1 b1 plus a2 b2 plus an bn, so on up to an bn. All right, so I hope you might have seen this. So if we dissect this, what is dot product? The dot product is also known as the scalar product. Okay, it is also known as scalar product, and it is the operation that takes two equivalent sequences of numbers, which is also called as which is usually the vectors. Okay, which is usually vectors, and the return or the result will be a single number. Okay, the result or the return will be a single number. All right, yes. Okay, fine. Now without any delay, we will see what are the properties of the dot product. Okay, the properties of, let me write it down, properties of dot product. Okay, the first property is the commutative property, which is well known. The commutative property is nothing but it is a into b is equal to b into a. Okay, so with the property we will solve one example, so it will be easy. Okay, so let me take one example. If a is equal to 1 2 3 and b is equal to say 4 5 6. Okay, so what is a into b? A into b is equal to 1 into 4 plus 2 into 5 plus 3 into 6. Okay, so it is direct multiplication by first number of the first vector, first number of the second vector, second number of the second vector, and second number of the second vector. All right, so if I do that, I'll get 32, and if I do b into a similarly, I'll get 32. Okay, so if I say that it is a into b is equal to b into a. The second property is a distributive property. Okay, so what is distributive property? It is nothing but it is a into b plus a, b plus c is equal to a into b plus a into c. Okay, so one more vector I have to take here. So c is equal to, say I will take it as 7 8 9. Okay, and I know what is a and b. Okay, so if I say that, so I have to do a into b plus c, right? So it is nothing but a into 11 13 and 15. I'm writing it directly, since I know what is b plus c. I'm writing it directly. You can do stepwise. All right, you just have to multiply, add two vectors b and c. So now I'll multiply 1. So the a vector is 1 2 3, so I'll multiply 1 into 11, 2 into 13, 3 into 15. So I'll get the answer as 11 26 and 45. So the total will be 82. Okay, now if I do a into b, I know it is 32, because I have got it in the first property, the commutative. A into c, if you do, you will get the answer as say it is 50. Yeah, 50 if you get, and you get if you add it, you will get 82. I'm directly writing it in order to save the time. Please pause the video and you can repeat it. Okay, so next third property is it is the scalar multiplication. So what is scalar multiplication? Any number you are multiplying with the vector. Okay, so it is a constant. So c into a is into b is equal to c into a into b. So you can take any scalar as a positive real number. You can take any scalar. So the let c be, it is equal to 2, and if you multiply, what you will get, it is 2 into a into b is equal to 2 into 1 into 2 into 2 into 2 into 3, right, into 4 into 5 into 6. Right, so I'm just multiplying it. So you will get 2 4 6 into 4 5 6. So if you multiply these two, what you will get, it is 2 into 4 plus 4 into 5 plus 6 into 6. So you'll get the answer as it is nothing but it is 88 plus 20 plus 36. So you'll get the answer as 64. So now if I do the other thing, so it is 2 into 32 is equal to 64. Okay, Okay, fine. Now I got the answer as that 64. Now if I do the similar for the upper numbers, you will get the left hand side is equal to right hand side. Now the fourth the property is the positive definiteness. What do you mean by that? So positive definiteness means it is a into a should always be equal to greater than or equal to 0, and a into a is equal to 0 only if a is equal to 0, right? I hope you know this. So let me take one vector for a as say 1 2 3, and if I multiply a into a, what I will get, it is nothing but 1 into 1 plus 2 into 2 plus 3 into 3, 3 into 3, which is nothing but it is 1 plus 4 plus 9, which is nothing but 14, which is greater than or equal to 0. So if I say a is equal to 0 comma 0 comma 0, then I'll get the answer as a into a is equal to 0. Okay, so that those are the four properties. So one more important topic under dot product is the geometric interpretation of the dot product. Okay, the geometric interpretation, and this is important. Okay, this is very important. Yeah, so what is the formula for geometrical interpretation? It is nothing but a into b is equal to magnitude of a into magnitude of b into cos theta. Okay, now let me take one example and we will solve for how to find with the vectors and find the angle theta. Okay, yeah, so the first example is so let a is equal to 3 comma 4 and b is equal to 4 comma 3. Okay, we have to find theta, okay, which is closed under some real number r square. So a into b, we know this how to do it. So it is 3 into 4 into 4 into 3, plus 4 into 3, which will get it as 3 plus 12, 12 plus 12, which is nothing but 24. Okay, now how to find the magnitude? I hope you know this. Magnitude of a is equal to nothing but it is equal to root of 3 square plus 4 square is equal to 9 plus 16, which is equal to root of 25, which is equal to 5. Now what is magnitude of b? Magnitude of b is nothing but root of 4 square plus 3 square, which is nothing but 16 plus 9 is equal to root of 25 is equal to 5. All right, now we know the three terms in the equation, so we can find out what is theta. So let me write it down. So a into b is equal to magnitude of a into magnitude of b cos theta. So what it will be, a into b is equal to 24 is equal to 5 into 5 cos theta. Yes, 24, let me write 24 is equal to 25 cos theta. So what is cos theta? Cos theta is equal to 24 by 25. So what is theta? Theta is equal to 16.26 degrees. So what we can interpret it from this is that the dot product not only provides the measure of how aligned two vectors are, but also allows us to calculate the angle between them. So this is one example that shows how dot product to find the angle between the two vectors in the plane, illustrating the geometric interpretation of the dot product. So the next topic will be the inner product, so stay tuned for it.